Okay, welcome back to another episode of How to Geometry. In this particular video, we're going to look at solving equations for the missing side links and missing angles in right triangles. Be sure to hit the subscribe button, like, comment, and let me know what you guys think. So let's get it. All right, using trig ratios to find side links. Let's first recall what a trig ratio is, right? If we have a right triangle, there are three trig ratios that we can identify, right? Sine, cosine, and tangent. And we're taught that there's a relationship between the trig ratio, or the angle, and the sides, rather, and that's the trig ratio, right? So for instance, sine is opposite. I want to write this. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. And the acronym that we use is SOHCAHTOA, right? Everything revolves around understanding how to use SOHCAHTOA and when to apply it. So in this particular scenario, and this is just recalling, right? Like we're just recalling this. This is so if I wanted sine of A, right? Sine of A would be opposite over the hypotenuse. So 4 over 5. Well, let's say cosine of B from the perspective of B, it's going to be the adjacent side again over the hypotenuse. So this is actually 4 over 5 as well. And then tangent from either one of these, let's just say A, tangent of A, opposite over adjacent, we'll have 4 over 3. Right, so here in this scenario, we're given the 3 side lengths. And if I know the 3 side lengths, then I can tell you what the trig ratios are going to be. All right. Another scenario might be that you're given an angle, like you're not necessarily given the sides. So in this case, if I wanted sine of A, or even cosine of A, or tangent of A, well, in this case, A would be 20, right? Because that's the angle that's given to us. And this is calculator work for sure. We're going to use sine of 20 in the calculator, and we ensure that our calculator is in degree mode. Cosine of 20 and tangent of 20. All right, so in this case, sine of 20, if we take it to 4 decimal places, would be approximately 0.3420. Cosine of 20, 0.9396. And last, tangent of 20 would be 0.3639. All right, so this is the 2 scenarios when you're using trig ratios, right? Finding trig ratios. All right, we're going to use this idea and we're going to try to solve for side lengths and angles. So let's see some examples. All right, in this problem, let's look at what we're given. So we have a right triangle, obviously, and we want to find x. So we're given a side, 50, and we're given an angle, 53. So from the perspective of the given angle, what sides are we dealing with, right? Like, are we going to use? So from 53, this is x is definitely the opposite side, and 50 is going to be the adjacent side, right? And this is all from the perspective of the angle that we're dealing with, that we're given. All right, so opposite and adjacent. Thinking SOHCAHTOA. Opposite and adjacent is definitely going to be TOA. Tangent, right? Opposite and adjacent. So we write this. Tangent of whatever the angle is, in this case it's 53, is equal to opposite over adjacent. So x over 50. And now we have an equality, right? It's basically an algebraic expression at this point, right? Because there's a variable, x. We don't know what x is. X is a side length. But we want to isolate x. And if you think back to algebra, I can do anything I want to this equation so long as I do it to both sides. So what I'm going to do is I want to multiply both sides by 50. And the reason being is because we're trying to isolate the x and get the x by itself. So when I do this, we're going to get x, the side length, is equal to 50 times tangent 53. And this is for sure calculator work. So let's go to our calculator. All right, so tangent 53 times 50 is approximately 66.3522. Now, you may have a longer decimal in your calculator. The idea is that so typically we're going to truncate to 4 decimal places. And they may be saying, okay, well, what's truncate mean? All right, essentially what we're doing is, since we want to truncate to 4 decimal places, so we count 4 decimal places, and then we chop the rest of the decimals off, and we do not round. That's an important thing. Like we cut it off, just snip it, and then we don't round. So do not round. That's the language that you'll typically hear and see. All right, let's see another example. Okay, find A and B. Okay, what are we given? We're given an angle, and we're given a side length. Here, the side length we're given is the hypotenuse. Okay. Doesn't matter which one we do. Let's start alphabetical. So let's start with A. So if I want to find A, in every problem, we're typically going to be using SOHCAHTOA, right? Or the acronym to help us figure this out. So from the perspective of A, which is 36 degrees, what we know is the hypotenuse, right? So since I know the hypotenuse, in terms of SOHCAHTOA, tangent is no good to us, right? That doesn't involve the hypotenuse at all. If I tried to use tangent, I would get opposite over adjacent, which is B over A, and that tells us nothing, right? So we need to utilize the hypotenuse for sure. And since I'm looking for A, the side next to the angle, in reference to 36, A is the adjacent side. So this is definitely going to be cosine. So cosine 36 degrees is equal to the adjacent side, which is A, over 10, the hypotenuse. Okay, multiplying both sides by 10, because A is in the numerator. 10s are going to cancel, and we get A is equal to 10 times cosine 36. And straight to the calculator. We'll take it to 4 decimal places. So A is equal to 80901. Okay. Moving right along, let's try to find B. Okay. Again, in terms of SOHCAHTOA, opposite and hypotenuse, in reference to 36, B is opposite. So that means we're going to use sine. Sine of 36 is equal to B over, right, opposite over hypotenuse. So in this case, 10. Okay, solving for b, we're going to multiply both sides by 10. Right, to isolate the b, 10s cancel. And so we get b is equal to 10 sine 36. All right, going to our calculator. 10 sine 36 is approximately, like if we truncate to 4 decimal places, would be 58778. All right, see another example. All right, we're given 70 and the side opposite of 70. All right. Always writing down and keeping in mind SOHCAHTOA. Now we'll see which one is going to be actually useful here. Depending on what we want first. Let's go with A. So A, in reference to 70, is going to be the adjacent side. So opposite and adjacent. That's what we're dealing with. So it's going to be TOA. Tangent. So tangent of 70 is equal to opposite over adjacent. 9 over A. Okay. Solving this, there's a nice little property here that we're just going to switch these two. Right? Because, I mean, I can multiply both sides by A, divide both sides by tangent 70, and we're going to come out with the exact same thing. So what we learn is that we can just switch these two things. So this is going to be A is equal to 9 over tangent of 70. Right? You can swap. You can swap the variable for the trig expression. So to the calculator, we're going to get 9 divided by tangent of 70. So it's approximately 3.2757. Okay. Solve for little c. So for little c, which is the hypotenuse, in reference to 70, again, the opposite side. And now we have the hypotenuse. So opposite over hypotenuse. This is definitely sine, right? Opposite and hypotenuse is what we're dealing with. So little c is going to be, so sine 70 is equal to opposite, which is 9 over little c. Again, the variable is in the denominator, so we can swap these two. This is going to be little c is equal to 9 over sine 70. To our calculator, 9 over sine 70. Approximately 9.5775. All right, let's get a little bit more involved one. Okay, here we have a picture, and we want to find the area of triangle ABC. All right, first fact is that the area of a triangle is equal to, so area of the triangle, it's equal to 1/2 base times height. So base times height divided by 2. So in this case, the base of this triangle is 150 meters. The height, well, that would be the altitude We don't know what that is yet. All right, some other pieces of information we're given are 100 meters and 40 degrees is angle B. The measure of angle B is 40. So in relation to B, 100, well, this is just the hypotenuse. And H is opposite of 40. So if we think SOHCAHTOA, the one that's useful, opposite over hypotenuse, that's going to be sine. So sine of 40 degrees is going to be equal to the height of the altitude over the hypotenuse, in this case, 100. All right, solving for H, we can multiply both sides by 100. On the right-hand side, the hundreds cancel. So the height is going to be 100 times sine 40. Approximately 64, we'll call it 64.2787. Okay, now that's the height. We're not done. We're almost done. So to calculate the area, we need this number, right? 64.2787. We need that times the base, which is 150, and then divide this number by 2. So we can call this 4,821 in its area. So this is going to be square meters, meters squared. All right, so far, when we're given a triangle and we know an angle and we know one of the sides, then we can use trig in such a way that we can figure out the other sides. All right, so now let's try to find the angle. All right, so finding angles using trig. The way it's going to work is that we're going to be given some scenario, again, a triangle. All right, we're given a triangle and we want to find the measure of x. So we don't know what x is. However, what we do know, since x is located where x is, and the information we're given, so the side lengths 2 and 4, in relationship to x, 2 is opposite and 4 is adjacent. Now, in terms of sine, cosine, and tangent, the one that pertains to opposite over adjacent is going to be tangent. So this means tangent of, so here's where it's slightly different, because since, all right, since we're looking for an angle, we use inverse trig. And inverse trig is definitely calculator work. Like, there's no reason why you should have any of these memorized, right? With any of the trig at this point. I mean, at some point you'll learn the common ones, but that's at a much later time. So here, what I'm saying is that since we're looking for an angle, we have to use inverse trig. So that's what the tangent to the little -1 symbol. This is red. Well, I'll tell you what it's red later, but this is inverse tangent, right? Inverse tangent. This is what you use when you find an angle, when you want to find an angle. Tangent is opposite over adjacent, right? That doesn't change. That doesn't change. So the opposite side is going to be 2 over 4. Now notice we're putting the opposite over the adjacent side inside of the parentheses, right? Normally it would have been tangent of some angle equals opposite over adjacent. Here we're taking the inverse tangent of the opposite over the adjacent side, and the straight calculator work. So we go to inverse trig, inverse tangent, 2 over 4. And we get 26, we'll call it 27. 27 degrees, right? Because this is an angle. So x is equal to 27 degrees. Okay, now we can use trig to figure out the other angle, y, if we wanted. However, let's use the fact that there's 180 degrees in one triangle. So if that's the case, if this is a right triangle, 90 and 27 make 117 combined. So 180 minus 117, we're going to get 63. So y is actually 63 degrees. Okay. Let's expand our vocabulary rather. Here, the symbol that you see, most people call it a 0 with a line through it. I mean, that's very observative and it's an excellent description. However, this is a letter, right? It's a Greek letter. It's a Greek letter from the same alphabet as, say, pi, right? Pi is also a Greek letter. This particular letter is called theta. Theta. And what theta is, it's well understood that in mathematics that theta is reserved for the variable when referring to angles. So if we're looking for an angle, or if an angle is unknown, then theta will be the variable that we use. In the same way, when we use x in a problem, right? X is our variable, represents a number. Well, theta is the variable in trig problems, and it represents the angle, right? This represents an angle. Okay, so let's find the angle. Find the angle. Since we're looking for the angle, you should have some intuition here that we're looking for an angle. There's only one tool that we have in our box to find an angle, and that's inverse trig. Right, inverse trig. That's the only tool that we have. In relation to theta, we're given 1 and 3. So 1 is definitely the opposite side from theta. And then 3 is the hypotenuse, the longest side. So opposite and hypotenuse. Opposite, hypotenuse. Okay, so this is going to be sine for sure. Right, SOHCAHTOA is opposite over hypotenuse. So we want sine inverse, right, because we're looking for theta, of opposite over hypotenuse. So 1 over 3. And this is calculator work. So let's see. Inverse sine, 1 over 3. 19.4712. All right, so in summary, when we want to find the side lengths, we're going to... All right, so in summary, when we're looking for the side lengths, we're going to use trig functions, sine, cosine, and tangent. We're going to set up the appropriate equation, or proportion rather, right? It's going to be one of the three, sine, cosine, or tangent. whatever the angle is and the appropriate ratio, opposite over hypotenuse, adjacent over hypotenuse, and opposite over adjacent. And then solve for x. Whether x is in the numerator or x is in the denominator, we're solving for x. If we're looking for the angle, SOHCAHTOA still applies, except now the ratio, right, will go inside the parentheses, and you're going to use the inverse function on the calculator. Hopefully you found this useful. As always, like, comment, subscribe if you haven't done so already. Let me know what you guys think, and I'll catch you in the next video.